The last thing that we're going to take a look at in this lecture is the relationship between the Nusselt number, which we just saw. We came up with an expression for the Nusselt number for a vertically heated flat plate, and the relationship between that and the non-dimensional numbers that are important for free convection, Nusselt number obviously being one of them, but typically what we find is that the Nusselt number, and so let's assume that we're expressing this in terms of the length of a plate, it is going to be a function of a number of different non-dimensional variables, the Reynolds number being one of those. Another one would be the Grashof number, and that is the non-dimensional number that fell out of our non-dimensionalization of the governing equations. And then finally the Prandtl number. That is an important number again. We saw that for forced convection. It pops up again with natural convection. It's basically a ratio of our viscous to thermal diffusion. And so what we have here is we have, depending upon the Grashof number and the Reynolds number and the ratio of those, we could be in different types of flow regimes. So to begin with, if we have the Grashof number, remember the way that we got the Grashof number, we multiplied our governing equation by Reynolds number squared. That's why we're dividing the Grashof number by Reynolds number squared here. But if this ratio is approximately equal to 1, we have a flow regime that is referred to as being combined free and forced convection. And consequently, for this, we know that the Nusselt number is going to be a function of all three, the Reynolds number, the Grashof number, and the Prandtl number. If we have a flow where the Grashof number divided by the Reynolds number squared is much less than 1, that would be a higher Reynolds number flow, and that would mainly be forced convection. And here what we could say is our Nusselt number would be a function of Reynolds number and Prandtl number. And then finally, if the Grashof divided by the Reynolds number squared is much larger than 1, that would be mainly free convection. And in that case, the Nusselt number is going to be a function of the Grashof number and the Prandtl number. So those are some of the orders of magnitude analysis that you can do when you're looking at this. And finally, one thing to say, we did come up with a correlation or a relationship for the Nusselt number for a vertically heated constant temperature flat plate. But typically what we often do is we will use empirical relationships. And the reason why we do this is because quite often the shapes aren't as simple as just being a vertical plate at a constant temperature. And the relationship that we use here is, you'll see the subscript F denoting that you're evaluating the properties at the film temperature. So we use these coefficients C and M, and the film temperature is T infinity plus T wall divided by 2. Or if you're using Ts for the surface temperature, it'd be divided by 2, same thing. And another thing that we have here, C and M, are in tables. So look in your heat transfer book and I'm sure you'll find them. And the final thing is, notice that in the equation here we have Grashof times Prandtl. That is a non-dimensional number that is often appearing when we're dealing with natural convection. And sometimes what happens is that that is combined together into a new non-dimensional number referred to as being the Rayleigh number. Heat transfer loves non-dimensional numbers. We have a lot of them in heat transfer. But it's the Grashof times the Prandtl, and that gives us the Rayleigh number. And you'll see the Rayleigh number quite often in correlations for free or natural convection. So that's a bit of an order of magnitude analysis between free convection, forced convection, and combined free and forced convection. And it turns out that it is quite often difficult just to have pure free convection because you do often have mechanical forcing, people walking by, there might be ventilation in a room or something like that. And so it can be challenging just to have natural or free convection. You usually are in this combined mode. But anyways, what we've seen here is the way to be able to figure out orders of magnitude. And when either the free convection or forced convection would be applying.